In animals, the rate of aerobic metabolism is related to body size. If we plotted on a log-log scale total metabolic rate, in other words, total oxygen use in milliliters of oxygen per hour, and body mass in kilograms, in other words, that's 10 grams, 10 kilograms. On this log-log scale, as animals get bigger, they should increase their oxygen use. If an animal is 10 times bigger, we might expect 10 times more oxygen used. That would give us a straight line in which, if we had a 10-gram animal and we compared to an animal that was 10 times bigger, we would expect that animal to have a 10 times higher metabolic rate. And if we did that again, we would expect a 10 times higher metabolic rate. And a 10 times higher metabolic rate. But what we actually have is a curve that looks more like this. A 10x increase in body mass gives us only a 5 times increase in metabolic rate. And that's true all the way along the curve. 10 times gives us only a 5 times increase in metabolic rate. Mathematically, that straight line has a relationship of metabolic rate equals A times the mass. If the animal gets 10 times bigger, then the metabolic rate should increase by 10 times. But this curve is metabolic rate is A times mass to a factor of 0.7. When an animal gets 10 times bigger, that 10 times bigger to a factor of 0.7 means that the metabolic rate increases only by a factor of about 5. So larger animals are using less oxygen per gram of tissue. If we plot this as mass specific metabolic rate, in other words, milliliters of oxygen per gram per hour, from 0 to 8. And again, we have a log scale with body mass in kilograms. If we do this on a mass-specific metabolic rate per gram of tissue, we see a very different relationship. A shrew at a little under 10 grams is above 7 milliliters of oxygen per gram per hour. A mouse at around 20 grams is here, a squirrel at somewhere around 100 grams, a human a little under 100 kilograms, and an elephant somewhere above 1,000 kilograms. A mouse with 5 to 10 times the metabolic rate of a human, we might expect is also doing things 5 to 10 times faster. Those things might be growth, healing, and so on. That's true for metabolic rate. A mouse is using oxygen faster. Many events inside a mouse are happening faster than in a human. But there are still some limits. It takes the same time to build a protein or copy DNA. Diffusion happens at the same pace. But with respect to healing, if a mouse has to move cells and materials, it can move things faster from one part of the body to another. In some ways, being larger doesn't affect the rate at which things happen. Proteins are made at the same speed, but in other ways, size matters a great deal. The difference in metabolic rate with size has to do with how easy it is to transport materials, say oxygen, into the lungs, from there to the heart, and to the tissues and back. A mouse, with its very small body, can move blood very quickly from the heart to the tissues. A mouse has a pulse rate of 400 beats per minute, much higher than yours. It has a cardiac output of 20 milliliters per minute, and it only has a volume of about 1.5 milliliters. So every minute it is moving its blood through the entire circulation 13 times. So the time to get blood from the heart out to the tissues, oxygen coming in to the heart, out to the tissues, is 4 seconds. So a mouse can get oxygen in and to its tissues within something like 4 seconds. When a mouse is working hard, because of that short path length for the oxygen, it can replenish oxygen quickly. Now let's compare that to what happens in the elephant. The elephant has a pulse rate of about 30 beats per minute. It requires approximately 5 minutes to move blood through the system and back. Moving blood from the heart out to the various tissues takes on average probably something like 3 minutes, about 180 seconds. The elephant is moving oxygen and glucose and other nutrients at about 1/40th, 2 to 3% the rate of a mouse. That much slower movement of oxygen is most likely the limiting factor for metabolic rate in a large animal. Small animals can move oxygen very quickly to their tissues and back. They can move glucose from areas where it is being released to the tissues within seconds. An animal your size, or that of an elephant, is much slower. For human, it takes about 1 minute to move blood from the heart out to the tissues and back. That means that when you're working hard, you cannot replenish oxygen anywhere near as fast as a mouse, and that limits your aerobic metabolism.